Hi, my name is Zhihui Tian. I'll give my presentation for computer vision course, and my project is related to face recognition. My presentation mainly has four parts. The first part is introduction. The second part is related work. The third part is implementation, the experiment, and the final part is the conclusion. For the first part, I want to firstly introduce why we need face recognition. I think we can think this question from two viewpoints. The first viewpoint is the importance of face recognition. Face recognition have very important theoretical significance and application value. Research of face recognition has a significant role in promoting the development of image processing, pattern recognition, computer vision, computer graphics, and other fields. The advantage of face recognition has many four parts. The first one is convenient because face is a biological feature. Second one is not enforceable because it doesn't need people to cooperate. For the current virtual face recognition technology, people are recognized if the camera gets people's face. The third one is non-contact because people don't have to touch the device, which means safety. The fourth one is hair efficiency because face recognition system can recognize many people at the same time, which is more efficient than other ways like fingerprint recognition, iris recognition. I found some examples from the internet related to face recognition. For the first picture, we can find there are a lot of famous physics. By using face recognition technology, we can identify their face and use the rectangular to get their face. The second and the third pictures show us how our smartphone or iPad use the face recognition technology to unlock our device. So how to achieve face recognition? I have a related work part and the implementation part. For related work, I mainly talked about convolutional neural network, Euler algorithm, and deep face algorithm. For implementation, I have three implementations for this project. The first one is recognizing face from images. The second one is extracting features from images. The final one is recognizing face from videos. For related work, I'll firstly talk about convolutional neural network. The structure of convolutional neural network is shown in this picture. This algorithm usually have four main parts. The first part is input. The second part is convolution layer. The third part is pooling layer, and the final part is fully connect layer. I want to talk about convolutional layer. We can use the convolution kernel to convolute with our original image, to get the special feature of our image. For example, if I have a convolution kernel has this feature, the diagonal has the value of 1, I can find where of my image has this the same feature as with my convolution kernel. By convolution with crossed image, we can finally get the feature map. So for the feature map, for the higher value we get the corresponding area in the image, we have the same structure with the convolution kernel. The next layer is pooling layer. The function of pooling layer is to reduce the complexity of feature map. We can get a smaller feature map after pooling layer. After getting the smaller feature map, we can use the activation function to get the possibility. Another algorithm I want to talk about is YOLO algorithm. Firstly, the network divides one picture into S multiply S grid cell. For YOLO V1, we have S equal to 7, so we get a 49 grid cell, which is shown in this picture. And every grid cell can predict two corresponding bounding box. The bounding box can be small or can be large. Also, the bounding box can overlap with other bounding box. But as long as the center of bounding box is in the grid cell, it shows the bounding box are generated by the grid cell. The bounding box has 4 coordination, position, and creatability. And the value of creatability are shown are represented by the thickness of line. If we get a thick line, it shows they are more likely to have an object there. And the grid cell also can generate a conditional probability of all categories, like this picture. We can use we can multiply bounding box with the class probability map to get a final detection. In the final detection, we can detect our object and get their position. The final algorithm I want to introduce is DeepFast. Before introducing the exact how it exactly works, I want firstly introduce the development of face recognition. The scientists firstly found a way to use the application of border control and smart biometric, but it's vulnerable to unconstrained environments. After that, they use a create hand craft features approach, but it demands tons of thousands of feature descriptor. Until recently, we have DeepFast technology. It produces much more compact descriptor. For DeepFast, I want to focus on 2 parts of this algorithm. The first part I want to introduce is the facial alignment. Why we need facial alignment? This is because facial alignment can help us learn facial features in an easier way. Our face is 3D model, so 3D modeling is one way to do facial alignment. The way of 3D modeling in DeepFast related with a lot of knowledge, just like machine learning algorithm, probability knowledge, and 3D modeling knowledge. We finally get this image, image G, which is called final frontalized crop, and we can set it as our convolutional neural network input. Then I want to introduce the convolutional neural network in DeepFast. In the DeepFast algorithm, we have 3 parts of convolutional neural network. The first part have one convolution layer, one max pooling layer, and one convolution layer. They can transfer the aligned image into local features, and they share the weight across the whole image. The second part are different with the first part because they don't share with weights, and every filter can just scan or partial image rather than across the image. The final part of this algorithm is to layer of fully connected layer. The first fully connected layer transfers our information into feature vector, and the second fully connected layer transfer the previous information into classification. Then I want to show my implement and experiment. For I have three special module for this part, and I will show it in Jupyter Notebook. For the first module, I want to recognize face from images. So I use pictures from Big Bang Theory, and we can find that it will finally get 5 faces like this. And the second part of my module is extract features from person's face. And I can also show it on Jupyter Notebook. This is the original picture, and this is the picture processed by my algorithm. And the final module is recognizing face from videos. I can also show it by Jupyter Notebook. Yeah, it shows that my algorithm can recognize me, and with if I take the masks, the system also can recognize myself. That's all of my implementation and experiment part. And the final part is conclusion. So I learned a lot of things from this project. So this is my first attempt to access a computer vision project. I know how to process videos and images from this project. I also have a deep understanding of convolutional neural network, neural algorithm, and deep face algorithm. I think I will continue to study on this area. So thank you very much.